Hi everybody, here's Christian from Teamworkcast. Welcome to our Pico-8 hero session thingamajig. Today we are going to start something that is super difficult. Well, not super difficult, but super important. Today we are going to do collision detection. And as I teased last time around, collision detection is one of the fundamental things in game design. You can define, if you want, if you are one of those people. Let me fix my microphone so you can see what I'm saying. Yes, Christian, that's how it works. So game design, or let's say game programming, can be understood as a series of collision detections. Like when you, especially action-based games, where when you're controlling a thing and it collides with other things and you lose the game. When you shoot things and those things collide with things, you win the game, for like a shooter game. Or even something like a strategy game. It's like where you're controlling a mouse cursor, and a mouse cursor collides with buttons or units on a map, and then it issues different things. So yeah, so collision detection is a big deal, is what I'm trying to say. Right, so it has been some time since I last time around programmed here. So I have to kind of like get my bearings. Where were we the last time around? I did some changes. I renamed the file Hero1. So it's easier for me to load it up every now and then. Also, I did one cool thing, is I actually translated the German cheat sheet that I've been using. So now it says cheat sheet all the way up here. And I actually, while I was doing it, I actually found some cool things. For example, here, is it here? It's here. Here is actually the one, it's not here. It's not the newest version apparently. Oh man, awkward. So I want to show you this. If you type in folder, you cannot actually see it on my stream, sadly. But I swear, it opens up a folder, the Windows Explorer folder, of where all your cards are. And that can be very important when you're copying things, making backups and stuff like that. So one thing I did is, you can see there's a sync folder in here that I created, the pink one, sync folder. I created a GitHub repository so I can sync my different projects between different computers. I'm not going to show you right away how this works. I will do like a separate tutorial explaining you how GitHub works and stuff like that. Just making sure that you understand how you access your folders, your cards in your files, so you can keep making backups, so you can exchange those things. It's very difficult it's not very difficult, but it's kind of like difficult to explain where the folder is. You have to like change your Explorer in Windows and stuff like that. So it's easier just to type in folder and it pops up immediately. Another thing that I really like is about the new version of this is down here, maybe now it will focus. Down here are some really cool keyboard shortcuts that really help a lot. Something I did not know before I tried to do this. Oh, hey, Frozen Thork in the chat here. Something that I did not know is that with quick save, with Control S, you can quick save. This is kind of like fun, because like if you type in save, it prompts you to specify the file name, but if you are in the editor and you press Control S, it actually remembers the file name. So that's kind of weird. Like Control S remembers the file name, but the command in the thing doesn't remember the file name. So yeah, Control S, good thing to save, so you don't have to get out and remember where you saved last time around. There's also, that's also kind of nice, Control R runs the program. So you don't have to get out and type in run. You can just type in Control R and it runs the program as well. That's kind of nice. Yeah, you Control M mute and unmute and stuff like that. There is some cool stuff in here. Cool. So yeah, check it out. I'm gonna put a link to the cheat sheet in the YouTube doobly-doo, so you can download it. It's very, very useful. I'm using it myself because I forget all these things all the time. Cool. So today we are going to do collision detection. How does collision detection go? So what we're trying to do is very simple. We're trying to collide the ball that we have with the pad underneath, right? So right now there is no collision, as you can see, and we want to like figure out when the ball collides with a pad. I'm gonna blow your mind, guys. We already did collision detection. We already did collision detection. Do you remember when? We already did it. So we did it when the ball collided with the screen. with the edges of the screen. That is collision detection. We collided the ball with the edges of the screen. And so what we're going to do today is not much difficult, it's not much more difficult than that. Instead of making the ball collide with a huge rectangle that is the size of the screen, we're going to use the same technique to make the ball collide with a small rectangle that is the pad down underneath there. That is our strategy, that is our idea. And so this is generally, so let's review the code real quick and see how we collided the ball. How the hell did you collide the ball with the screen? So you can see there's two if statements that are checking the x position of the ball and the y position of the ball. Easy. So they're kind of like checking the left edge of the screen, the right edge of the screen, the top edge of the screen, and the bottom edge of the screen. Generally, it's kind of like collision detection can be difficult because it's something that's super easy for us to understand with our human brains. Our human brains are made to understand collisions and interactions with physical objects. So things that are obvious to us, that are like no-brainers for us, are kind of difficult to express mathematically because math wasn't made, not specifically made to deal with this kind of things, especially computers. So for us, it's easy to see, oh, that thing just bounced off it. But expressing this in code it seems a bit tedious if you compare it to how natural it feels. So you cannot just say like, oh, this object does it collide. There is no mathematical formula for this. Instead, what you have to do is you're gonna have to check all the boundaries one after each other. Check like x coordinates, y coordinates, one after another. I'm gonna explain to you. I'm gonna blow your mind with some amazing technology. I'm gonna activate Microsoft Paint, and I'm gonna explain you what I mean. So what we're going to do is first of all we're gonna assume that we're colliding two squares with each other. We could assume the ball is a ball. There is probably a formula for this, but I haven't looked it up. And I think it's more important to think of, to first understand how squares collide with each other. Because most of the times you will collide squares with each other. So I'm gonna blow you away with my amazing paint skills. Look at this. So I'm gonna draw this box. This box is, let's say this is our pedal, right? And then we're gonna have a second box. This is going to be the red box, and we're gonna assume this is our ball. And I know that this is not our ball. Our ball is actually looking something like this. Okay, it's in the middle here. There is a ball, right? But because we are using such rough pixels, we're just gonna assume it's a square. It's not gonna matter for this kind of situation. Again, if this was maybe billiard, if it was like a billiard simulation where like accurate collisions of balls against each other and stuff like that were important, I just used the word balls a lot of times, we would maybe do a different kind of approach. But I think for this case, it's fine if it's a square. So what we have to do is what we did here, where when we collided it with the screen, where we checked this edge. Let me see. We took like this edge, right? And we checked it against another edge, like for example this edge. So let's do this per hand. Let me take a thicker. All right, here, this edge, right? So we can see like, okay, is this on the left side of this one, or is it on the right side of this one? We can tell that, actually this is the wrong edge to check. We can tell that, for example, if the left edge of the ball, if that's in this area, right? If that's around roughly in this area, we can for sure tell that there is no collision going on. Because if this edge is in this area, then the ball must be somewhere around here. And then there is no collision whatsoever. If it's on the left side of the area, we're not quite sure. The jury is still out on that one. But in all those cases where it's on the other side, we can be sure that that there is no collision. And that's what we're going to do with each one of the edges, with each one of the 4 edges. So, you know, likewise, let me delete this real quick. Ziger in the chat here, nice. Nice, how are you doing, Ziger? Can I make it even thicker? Is that the thickest we can go? I'm so disappointed with you, Paint. Why aren't you? Oh God, this is getting worse and worse. How do I erase something big time in Paint? Help! Help! Ah, there we go. See? Right. So, you know, this was the first edge, and then there's the second edge where we go like, okay, let's take the top edge, for example, and we're gonna go like, okay, let's take this top edge, right? This one. And we can tell that if this top edge is beneath the bottom edge of the thing that we're checking the collision with. If this is somewhere where, if the top edge is somewhere around here, which means, you know, the ball is here or here or here or here, right? We know that the ball is not colliding. So, and again, you know, we're gonna proceed with the same strategy with all of the edges. And you can see if we do this 4 times, and we are still not sure if there is a collision, then we can be sure that there is actually a collision. We are just eliminating all the cases where we're sure there is no collision. And if we eliminate all the cases where there's no collision, then that means the reverse is true, that there is actually a collision. That's the strategy here. So I hope it's clear. We're kind of checking not for if the ball is collided. We're trying to eliminated all the cases where we are sure that there is no collision. And if we checked all the cases where there is no collision and we are still, you know, not sure if there is a collision, then we can be sure that there's collision. Is the reverse is true. Let me write the function. Let me start writing the function, and then we can see what's up. We're gonna call this ball box, or ball underscore box. I don't know. It's kind of weird. You kind of have to figure out your own way to name things. I usually, you know, you would go maybe something like bigger, like ball hit box or something. Then you would use like lower and uppercase maybe to make it a bit more readable. But I think for Pico-8 it makes sense to make because there's no upper and lower case. I think it's a good idea to be a bit shorter and maybe a bit more and risk the fact that you might be a bit cryptic. So there's going to be a ball hit underscore box. And I think this is the first time. I'm not sure if this, yeah, this is the first time where our function will actually return a value. Notice how, you know, in draw function, for example, actually this might be also the first time we actually created an actual function. That is our own function. Okay, so our function will return a value. And that works very easy. That you basically go return, and in this case we just want to return true or false. We're just gonna, for sake of just testing, we're just gonna return false. Anytime we run this function, it will always return false. And so with this thing, we can now, for example, somewhere here, let's say here, the way we check if the ball hit the screen, we can go if, and we can plug in our function into an if statement. So up here, this is our update function. We check the collision with the screen. We notice, okay, there is no collision with the screen, or we dealt with the collision of the screen, and then we go, okay, let's see if the ball has collided with the pedal. And so we go if ball box. We run our function. If the collision has happened, then, and then we do something. We don't know quite yet what we're going to do. Deal with collision. And what I'm doing right here is called scaffolding, which means, yes, it's Ziga is asking which language it is. It is Lua. What I'm doing is scaffolding, which says I'm not actually writing the code yet. I'm just writing, generally what the function is going to look like, how I'm going to deal with the function. So I'm going to do like something like this. I'm going to execute my function again. The function will return a value. It will return a false or true. So that's why I can just plug it directly into my if statement. And then if there's a collision, if the function has returned a true, then I'm going to deal somehow with the collision. Cool. So this function will also do something different from the previous function. So well, actually we already did this. Pay attention to this rect fill thing. You see that there is like a bracket, or I guess it's parentheses. People, let me know. Is this parentheses or bracket? I find it very, very frustrating to deal. I heard that bracket is British and parentheses is US American. I'm not sure, and it's very confusing because parentheses doesn't sound like the thing. And I think I already did it wrong previously. Right. So we open up the bracket and then we put some values separated by commas, and then we close the bracket. But with our function here that we created, there is just open bracket, close bracket. There's no values that we put in here. When you put values and give values to the function and execute a function modified by certain values, when you give values to a function, that is called an argument. And I like to imagine, I like the name argument because it seems like you're making an argument to the function, convince the function to do their job. It's like if you go like a function, go like function, make me a sandwich. And then you go, pretty please. Pretty. That's the argument, Or maybe the argument is gonna, I'm so hungry. That's the argument. You argue with a function, so to speak. I don't know. It's just always something I imagine. I have a very active imagination. But argument in this case means we are transmitting values to the function. So as you can see, we can use functions. We can send information to a function, and we can get information back from a function. So information becomes kind of like this tool for us. And the reason why I'm setting up all this stuff, because I could just go like ball collides with pad and don't give the function any values. I could make the function just get the values from the variables we had up here. But I'm setting it up this way because we're going to reuse this function later on to not just collide with a pad, but also collide with other things like pickups and the blocks that we're going to have in Breakout. So that's why I want to create like a universal function that can deal with different kinds of things we're colliding it with. Cool. So when we're setting up this function to receive values, we have to kind of define which values, how are the values called? How are we going to reference the values within the function when we receive them? People are saying. So people say it's called parentheses, and the square thing apparently is called a bracket, and then there's a curly bracket. All right, I'm going to try to keep this in mind. I'm sorry if I get it wrong. But yeah, all right. So parentheses. We're going to, inside the parentheses, we're going to define the kind of functions that our, the current values that our function will accept. We're not going to, for now, we're just not going to, we're going to make sure, like, because I don't think there will ever be a situation, I'm not sure if there's going to be a situation when a non-ball object will collide with something. And if that comes up, we can still write that function. So for now, I think most of the times the ball would collide with things. So we don't have to actually transmit any information about the actual ball. But we do have to transmit information about the box. So we're going to go like box X, box Y. So which would be like the X and Y coordinate of the left upper corner. This is going to be this one, the position of the corner. And then I like to go with but you can do it different as well. You could, for example, now you could do like this corner. But what I want to do instead now is like box W, box width, and box height. Because I think we have the information about our pedal is stored in a similar manner. We also have a width of the panel and a height of the panel. Right. So now I just put a bunch of stuff here, and now I can reference all these things by just going like box X. It's kind of like a variable, but this variable is only present within this function. Right. So let me call this function first. Like, because right now I'm calling it without any kind of arguments. So I'm going to call it now. And, you know, it's very easy. It's exactly the values that we have. I'm going to go pad X, pad Y, oops, pad W, and pad H, which height. Cool. So we're calling this function. The function always returns false. There's never collision. The function is really stupid right now. But just in case I make some mistake, I'm just going to run it. Okay, this works. I'm going to save it. Good. Now on to the actual business of colliding things. So let me just try to make the scenario that's happening here, this scenario. I'm going to try to check for this scenario. Okay, so I'm gonna go if right. So we're gonna have to find the lower edge of the the upper edge of the ball, right? We have to check where are our positions. Okay, we have ball X, there's ball X, and we have ball R, that is the radius of the ball. So we're gonna go ball Y, that's the center point of the ball. This is this point here. Minus ball R. That is the radius of the ball, which is kind of like this little line here, right? This thing here. That is the radius. And we're gonna just subtract the radius of the ball from the center of the ball. This is the value of the top edge of our ball. Right? And we're going to say if this is greater than box X, box Y plus box height. People say, did I put two box Y in arguments? I don't think I did. Did I? I did. Thank you so much. This is correct. Right. So now I'm trying to find the coordinate of the lower edge of the box, and that is going to be box Y, which is this edge here, plus the height of the box, plus this one. And that's how we arrive at the edge. And so we see now if this happens, if this edge is beneath this, then we can for sure say that return. We can for sure return false. At this point, we can eliminate all collisions. Easy. Of course, at the end, we're going to return false. So at the end, we're going to return eventually true. We're going to change this. So we're going to go through all the 4 cases. At each point, we can. By the way, when we execute return, when the return command comes, the function immediately ends. Usually, I hope this is the case in Lua as well. Usually, the function immediately ends, and the function returns the value, and nothing after a return is ever executed. So, you know, in this case, if we find this case, if this is the case, if the ball is actually underneath the pedal, then it returns false, and nothing else will get checked. Right. So we're gonna just copy this part, and we're gonna check for the other edges. For example, now we are already working with Y, so we can go now for this lower edge here, right? So this lower edge is ball y plus ball r. Now we're going a different direction. So we now no longer subtract the radius, but now we add the radius. And it's supposed to be like if this is smaller, if this is higher than the top edge of the box, which is box y, then we can also return false. This is actually easier to write. I should have started with this one. This is a bit easier to calculate. And now we're going to do the same thing, the very same thing with the vertical edges. Vertical? Yes, vertical edges. So it's the x values. So with this one and with this one. Grimtusk says, I might be getting myself a pocket chip. It includes Pico-8 apparently. Would love to play around with this. Yes, it includes Pico-8. It's now for free. You can download it. They have a really cool deal right now for $25 or so. You can get the Pico, not the pocket chip, but the chip, which is just the tiny little computer, and an HDMI module and controller. So you can add it. So it's basically a console for $25. Right, so we duplicated the x values. I mean, all the two statements. Now we're just going to basically replace all the y's that we had with x's. And here, instead of height, we're going to deal with width. Now, again, this might go a little bit fast now. But really, like if you go step by step through the math here, we're really just dealing with this one and with this one and checking it against the left edge of the paddle and the right edge of the paddle. Right. And so I'm going to run this to see if there's maybe some kind of bug, but there seems to be no bug. But you can see that nothing happens. Table flip! Of course, the problem is that now that the function is maybe returning functions, returning values and checking for the collision, but we're actually not dealing with a collision right now. So I want to do this. I want to deal with a collision. Do we have, let me add something, a new variable, which I'm going to call pad underscore c. I'm going to call this, so this is going to be a color of the paddle. We'll start with 7. And I'm going to plug it down here where we draw the paddle. This is where we draw the paddle. You remember perhaps this is, we're going to plug in pad C. And I'm going to turn the paddle red when there's a collision. Pad C equals 8. And then I'm going to go pad C equals 7. So, you know, first we set it to white, and if there's a collision, we set it to red, and on the next loop, we reset it to white again, and then C again for the collision. So now every time there's collision, the pad should turn red. And yes, it seems to be working now. Right. So far, easy peasy for breezy. We're gonna make it. Yeah, now it actually didn't hit the paddle. Even though it was on the lower part of the screen, it didn't hit the paddle. And you know, it makes sense if you write your own first collision thing, to check it this way before you deal with a second part, which is, you know, making sure that it reacts correctly. Cool. So far, so good. So far, so good. Now comes the part that often causes problems. So, you know, before we continue, I'm going to commentate here. Checks for a collision of the ball with a square. A rectangle. Just so we know what this function does, just so we know. And then up here, we're going to commentate check if, check if ball hit pad. Deal with a collision, cool. All right, so I think we're recording for half an hour now. So I would say we take a break here and see if we can deal with a collision in a meaningful way next time around. If you have any questions, post them down in the comment section on YouTube. Otherwise, see you next time around, guys. Bye bye. Always safe. Always safe. Control S.